whenever we talk about a bullet going into the wooden block. So such kind of problems actually there, if you notice, he don't mention anything related to time. What he tries to mention is initially the bullet started with a velocity of 100 kilometers per hour, and then actually it is going into the wooden block and finally it stops there. Now how much depth it is going to go inside? That is the kind of question you can expect. Now in such kind of cases, if you notice, the bullet started with a velocity of 100 kilometers per hour. So that means the initial velocity of the bullet was given. In the second case, finally it went into the wooden block and stopped there. Obviously it will stop after going to some extent. Now when it stops, that means the final velocity of the bullet is going to be 0 because it stopped there finally. So initial velocity 100 kilometers per hour and the final velocity is 0. And then actually he asked us to find out how much depth, which is nothing but the displacement he asked. How much depth it is going into the block. That means the displacement was asked because he has given v and he has given u and the only unknown value is x here. So there actually there is no need of having the time. So that's exactly the reason why we use the formula like this. So this formula is very much useful whenever we are dealing with the bullet and the wooden blocks. So or actually suppose if the raindrop is coming from the top, then actually in such kind of cases actually we are dealing with the help of the time. In the first second, how much distance it traveled. In the second, how much distance it traveled. Now, such kind of questions actually there, as he is talking about the time, we are going to use this formula, or actually we are going to use this formula. So, if velocity is needed, then we use this formula. If the displacement is needed, then actually it is going to give the formula x is equal to ut plus half at square. So, x is expressed as a function of time here. Here, the velocity is expressed as a function of x. And here actually, v is expressed as a function of time. See this, v is expressed as a function of time here and as a function of x here. The same value. Both are equivalent. Got it? So this is the third case. And from this actually, there are certain cases. Like actually, the distance traveled in one particular second. That means, see this, if I ask the question, I traveled from one location, Bhimavaram to Vijayawada. While traveling, actually, I keep on raising my car speed. Now, actually, I am interested in finding out from 9th second to 10th second how much distance I traveled. So that is the distance traveled in 1 second. But that second varies because the velocity in each second is different. That means, suppose if I see this, let us say this is the time graph and this is the velocity, time and velocity. I keep on raising my velocity. That means here actually let us say I started with 10 kmph, kilometers per hour. Then at t is equal to 0, I started with a velocity of 10 kilometers per hour. In the very next second, I know that actually I am going to travel, so 10 kilometers per hour, right? Or actually in the very next hour, I know that actually as I am traveling with 10 kilometers per hour, I am going to travel for a distance of 10 kilometers. In the next hour, what I have done was, I traveled with a velocity of 20 kilometers per hour. So if I travel with 20 kilometers per hour, then actually the speed is raised. Hence actually the displacement is also going to be raised. So from here to here when I travel, here I traveled only 10 kilometers. Now the speed is raised to 20 kilometers. Hence actually within the same hour actually I am going to travel 20 kilometers. That means suppose I started at morning 10 o'clock. And then actually I traveled till 11 o'clock. I traveled with a velocity of 10 kilometers. Hence actually, so I traveled only the distance of 10 kilometers. In the 11 to 12th hour, what I have done was I raised my car speed and I am traveling with 20 kilometers per hour. That means in 11th to 12th hour, I have traveled a distance of 20 kilometers. And in the third hour, that is from 12 to 1, I traveled with a velocity of 30 kmph. Then actually, I know that actually I am going to travel a distance of 30 kilometers. Now actually, here if I notice, I keep on raising my velocity uniformly in each and every hour. That means I am raising my velocity constantly, meaning I am maintaining a constant acceleration. So A is equal to constant. So in that case, actually, as I keep on raising, that means as I keep on changing my velocity, obviously the distance traveled in each second is different. If it is a continuously raising, then in such case, the distance I traveled in the first hour is not matching with the distance that I traveled in the second hour. And the distance I traveled with the third hour, it is not matching anywhere. If I am asking you, suppose in the second hour, how much is the distance you traveled? If I specifically ask about one particular duration, then that time actually whatever the formulas what we have derived, that is of no use. So we need to be deriving one more formula where to find out the distance traveled in one specific second or one specific time. So what we can do is, suppose if I am asking you in the 10th second, how much distance actually you traveled? So there actually the nth second means n and n plus 1. So that is the nth second, the displacement traveled in nth second, meaning, so nth second meaning, suppose actually 0 to 1 second, meaning this is what we consider as the first second, and 1 to 2, this is what I consider as the second second, and 2 to 3, I consider this as the third second, right? Now, n minus 1 to n, I consider this as the nth second. That means, what I will do is, starting from Bhimavaram, when I am traveling till Vijayawada, I know that in the nth second how much distance I traveled. If I have to count it, then actually I count till n seconds how much distance I traveled, and then I count till n minus 1 second how much distance I have traveled. Then actually I will subtract one from the other so that I can get the displacement in the nth second. So that's what we call as the x nth second. So xn. So this is what is interested. This is x nth second. So nth second displacement. Now, if I have to do that, I know that in n seconds, how much distance I traveled can be given by un plus half an square. Because here t is nothing but n seconds. So t is expressed in seconds. So I have just substituted n. And then in the n minus 1 second, x n minus 1 second, u into n minus 1 plus half a into n minus 1 whole square. This is when t is n minus 1 second. So this one, nth second is the first case and n minus 1 is the second case. Now if I subtract one from the other, that is x nth second is nothing but xn minus xn minus 1. Xn is un plus half an square minus un minus 1 plus half a into n minus 1 whole square. So this is nth second displacement that is I am going to travel it. Now if I simplify this equation to the smaller extent, then actually it is going to give one specific formula, that is x nth. So x nth second is equal to un minus un minus 1 plus half a into n square minus n minus 1 whole square. So this is the simplified form. Now this u into n minus n plus 1 plus half a into, so this is a square minus b square format. So a plus b into a minus b. So this is n minus n will cancel out, and this is n minus 1 will cancel out. This is going to be u plus half a into, so this is 2n minus 1, or this can be expressed as u plus a into 1 by 2 if you take inside n minus 1 by 2. So this is the displacement that I traveled in the nth second. Got it? Displacement I traveled in the nth second. So here actually this is u plus a into n minus half. Any questions on this? Any questions? Got it? So here actually, if you notice, there is one fundamental question. So this is the displacement and this is the velocity, right? And even this one, n minus half into a, this is considered as the velocity.